Hello guys, today we're going to study 2.7 inverse functions. So before we're going to start, we're going to look at what is the definition of the inverse of a function. So you can pause this video and then look at the whole definition. I'm just going to highlight a couple parts, okay? If we have f of g of x equal to x for every x in the domain of g, and g of f of x equal to x for every x in the domain of f, okay, you realize they're all equal to x. Then we say the function g is the inverse of the function. So we're going to write it in this form right here. That is f inverse. So we say f of f inverse of x is the whole thing equal to x. And then we say the domain of f is equal to the range of the inverse function, and vice versa. Example 1, we want to verify in the inverse function, show that each function is the inverse of the other. So we basically just use the definition, guys. F of g of x, this whole thing equal to x, and then we say we have to check both condition. Alright, so let's look. F of g of x we have learned right from the previous lesson. So if we have this, we're just going to rewrite f of g of x. We say the g of x is x minus 2 over 3. So all I'm doing is just do a substitution. Okay, then once we have this, and then we look at the f function, every x you see here, replace it with this inside is a parenthesis. Okay, so we have 3x, that will be 3 times x minus 2 over 3. And then we have a plus 2. Again, we'll just replace your x right here with your x minus 2 over 3. So we're going to simplify this. We're going to have equal to, alright, they're going to be canceled out. 3, that will be gone. And then x minus 2 plus 2 is just going to give you x. We also have to check g of f of x and see if that give you x as well. This time we're going to plug in f of x. So here we have f of x, right? So we're going to write 3x plus 2. So that is my f of x. So basically we're just doing the substitution, put our f of x in here, the green color. So once we have this, we'll look at the function g function. Every x I see right there, I'm going to replace with 3x plus 2. So I see an x right there, so I'm going to write 3x plus 2, right? That's for my x. And then minus 2 over 3. So once we have this, so we're going to simplify it. That will be 3x plus 2 minus 2. That will just give you 3x over 3. They cancel out. So you're going to have x. So basically we're going to have this whole thing, right, equal x. Also we have a previous. We got this part equal to x. And then we'll look at the definition. By the definition of the inverse functions, then we can say f of x and g of x is inverse of the other. That is how you verify. Example 2, finding the inverse of a function. So here we're going to have the step by step, okay? So I'm going to write down the step. Step 1, replace f of x with y. So we have f of x equal to 7x minus 5. So I'm going to replace f of x y equal to 7x minus 5. Step 2, interchange x and y. So if I see a y, I'm going to change it to x, and then I see x, I change it to y. Step 3, solve for y. So in this case, I'm going to subtract 7y both sides. I'm going to have negative 7y. And then I'm going to move the x to another side. Positive become negative. That will be negative x minus 5. So once we have this, we're going to divide by negative 7 both sides. So I'm going to have this going to be canceled out. We're going to have y equal to negative x minus 5 over negative 7. So I'm going to simplify it a little bit. So I can take the negative out. That will be x plus 5, and then we have negative 7. So the negative sign is going to be canceled out. Then we're going to have y equal to x plus 5 over 7. Step 4, we're going to have f inverse of x, just going to be x plus 5 over 7. So that is your final answer right here. Okay, let's try another one. So we said step 1, we're going to replace the f of x with y. Step 2 is interchange x and y. So this one, that will be x equal to 5 over y plus 4. Step 3, we have to solve for y. You have to be really careful on this case, okay? So a little bit complicated. So what we're going to do is we have to multiply by y every single term. okay, because we want to solve for y. And then we're going to have xy equal to, this is going to be cancelled. That will be 5 plus 4y. So we multiply y every single term. I give rid this denominator. We're going to put all the y to the left side and everything else to the right side. So in this case, I'll have xy, alright, this move to another side and become negative 4y equal to 5. Be careful on this because you guys are not used to it. Once we have this, remember you are solving for y. We're solving for this. That's why we put them all together. Now we're going to factor y out. I'm going to put it right here. And then what left over here, that will be x minus 4. And then the right side, we're going to have 5. Once we have this, then we're going to divide by x minus 4 both sides. So let me just explain it. So I have some students struggle this. If you had a 2y equals 5, you know you have to divide by 2, right? So this is the same concept. You have to treat this as x minus 4 just like you treat 2. You divide by 2 both sides. Once you have this, so we're going to just cancel x minus 4. We're going to have y equal to 5 over x minus 4. Once we have this, we said the final step is we're going to replace y with f inverse of x equal to 5 over x minus 4. So this is your final answer. So next is the horizontal line test for inverse function. Let's look at example 5. This should be pretty quick, okay? I'm not sure if you guys ever heard this, alright? So inverse function must be one-to-one function, okay? If you don't know, I'm going to explain to you, alright? It's a one-to-one function. What you're going to do is I'm going to have a horizontal line test right here. So what happens is you only intercept once. That means you pass the horizontal line test. In this case, yes, it has inverse because it only intercept once. The next we're going to look, we have intercept twice. That means no, because we only can have once. Right, not inverse function. Then we look at the next. That intercept more than one. That's actually 3 points. That means not again. Okay, and then you look at this. It's always is only 1 point. That's why you're gonna have yes, inverse function. So only the one-to-one function has the inverse function. Next, we're going to look at graphs of f and f inverse. Okay, so let's take a look. I just gave you the graph. So here we have two things, if you guys can see. So the blue color right here, that's a graph of f. If you look at these small words, it says the graph of the inverse, alright, is f inverse is a reflection of a graph of f about y equal to x. So this is your reflection right here, alright, the pink line or red or pink, okay? So that means if this is 1, the older pair, if your x is 1, y that will be 1, okay? If your x is 2, y that will be 2. So that's where that line comes from. In the past, we did x-axis or y-axis reflection. Now we're dealing with this is your reflection. Thinking about this is your mirror. And then we're going to say the inverse function just a reflection of your f about y equal to x, this line. So this is where the reflection is. Another thing is so important you need to know. If you look at the points right here, the points right here in this case is A, B, and then here you realize the older pair actually become BA. Okay, they actually change. So let's take a look how we graph this. So let's go ahead and draw that reflection first. So I'm just going to go ahead, you draw this y equal to x. Alright, then I'm going to work on my reflection. Let's go to look. We have points 4, 2. That means my new point that will be 2, 4 because we're just switching it. So then we look at the next points is negative 1, 0. Then the new point that will be 0, negative 1. So right here, that will be 0, negative 1. And then here we have another point, so negative 3, negative 2. Then we're going to have negative 2 and then negative 3. That will be right there. Okay, again, the older pair just going to be exchanged because earlier what we did is we changed the x and y. Remember, that's how we solved for inverse. So now we're going to connect all those points and then we finish this question. Remember, there's just a reflection about your y equal to x. And then we switch the older pair. X become y, y become x, and then you finish your graph. Okay, so you are done. Example 7, finding the inverse of a domain restricted function. So in this case, given us f of x equal to x squared minus 1 if x greater or equal than 0. So we need to graph the f and the f inverse. So we'll just say this is the part A. Alright, before we start finding the inverse function, so we realize something. Hopefully you guys realize something. X squared minus 1, okay? It's just a quadratic function, right? It's a quadratic function moved down 1 unit. So actually you're going to have something like this. And then we also said, okay, if we have a function x squared minus 1, I shouldn't have an inverse function because it wouldn't pass the horizontal line test, because I only one-to-one function, which it means only the function passes horizontal line test that has an inverse function. So in this case, it shouldn't have an inverse function. But wait for a second, okay? If we talk about x greater or equal than 0, all you are saying is we're only actually dealing with the right side is a half, okay? Because we said that means we only care the other side. And then now you look, that will pass the horizontal line test. That is just something we have to think about. Okay, now we're gonna go back here because step 1 we'll need to find this, right? So given to us, I'm just gonna rewrite this. F of x equal to x squared minus 1. So we say in here x greater or equal than 0. And then we're gonna replace this with y equal to x squared minus 1. We still write this down. Restriction. Alright, there's a reason. I'll explain just in a little bit. Once we have this, we're gonna change this. That will be x, and then we'll turn x to y. That will be y squared minus 1. Once I interchange x and y, what happens is our restriction changes too. Earlier we restrict x, now x become y. That's why I changed this as well. Step 3, we said we had to solve for y. So I'm going to isolate y squared, so that will be x minus 1 equal to y squared. So I'm just going to rewrite this as y squared equal to x minus 1. Remember, we have restriction. I'm going to continue write this just to remind us, okay? Then once we have this, I'm going to take a square root of both sides because they're going to be gone. So before we move on, let's wait a second. When we take a square root of both sides, we remember in the past, alright? My teacher always tell me I have to do positive negative. But the thing is, since our y is greater or equal than 0, because of this, that means that we do not care about negative. Alright, that means we only need the positive one. So I just delete that negative sign. So let's continue, finish this. That means I'm going to have y equal to square root of x minus 1. Finally, we're going to replace this step 4. That will be x inverse, just going to be square root of x minus 1. And then once we have this, we need to graph this. So now we're going to graph. So actually, I already did some graphing early. So I'm going to graph f of x equal to x squared minus 1. So this, we're just going to plug in, alright, couple points. Because our restriction x must be greater than 0, so I really don't care another half. So should I make a table? I guess, okay, so maybe I'll just write it right here really small. So if I have the 1, I'm going to plug in 1 here. 1 squared minus 1 is going to be 0. So if I'm going to plug in 2, for x, 2 squared, that will be 4, and then that will be 3, okay? If I plug in 3, this is 3 squared, that will be 9. 9 minus 1 is just going to be 8. So basically, I find this couple points for this graph. So let's go ahead and plug it in. I'm going to have 1, 0. Let's plug in 0 as well, okay? If I have a 0, 0 squared minus 1, that's going to be 0, negative 1. Let's make sure plug these points as well. And then we're going to have 2, 3, 2. So I just plug in those points, okay? I plug in these 4 points from here, okay? And then I did this graph. That's my f of x, okay? Remember, because they want you to graph f and f inverse. So I have this couple points. Okay, so I just labeled these 4 points, okay? Now I have the graph inverse. Remember the inverse, the reflection of y equal to x. So I'm going to draw the y equal to x. Next, let's just go ahead and do this. We're going to do the reflection. The order pair 0, -1 just become -1, 0. And then 1, 0 becomes 0, 1. And then have 2, 3 becomes 3, 2. And then we look 3, 8 become 8, 3. And then we're gonna have this. Then we're gonna connect all the point. Part B, we did the graph, we just finished it. F and F inverse. Okay, let's add this part C because in your homework they ask you these questions. Let me add part C. Use interval notation to give domain and range of f and f of inverse. So this is a question already given to you. So you can either look at the graph. Let's go ahead and do two ways. Look at the graph or the function. So let's look at the graph. That is the black color. Okay, domain. Remember, domain of f, we're just looking at our x. Okay, you've done this in the past. So you look at your x-axis and then we'll look what happens to your graph. Okay, so left or right, that means it's a start 0, right? So we'll look at this line I'm matching here. So that means I'm looking right here and see what happens to my graph. And then you realize the graph is from 0 to the positive infinity. If that doesn't make sense to you, let's go back to the question. So if you look right here at the beginning, they said f of x equal to x squared minus 1 if x greater equal than 0. You could just thinking about this. They given to you x greater equal than 0. Okay, so this is on the number line gonna look like this, right? So we say this is 0. And then it's greater equal than 0. That's a solid line. So we're just gonna say, oh, okay, that is basically everything to the right side that work. So then you write it in the notation form. You can do that. Okay, if the graph makes sense to you, so you read the graph. If the graph doesn't make sense to you, you do use a different method. Okay, so you also can double check. We said the domain of f is a range of your inverse. So if you look at the yellow color, the range of this yellow color, which is the inverse function, you look at the range, you look at up, down. Up, down, this started, up, down, let's use this color. It's actually started here and then going up, up, right? And that's another way to look at it. Okay, you still get the same answer. You start at 0 and then go up forever. That will be positive infinity. Alright, so the second part, range of f, is the domain of the inverse. So we'll look at the range of f. That just looking up, down. Remember that from black color, you're just going to have from -1 to the positive infinity. So that is, you're looking here. Let me see if I can find it. Okay, let's use the green color. We started right here and going up. So that is, my solution is from -1 and going up forever. Again, if that doesn't make sense to you, let's think a different way. So we look at the f inverse function. We said this is equal to, right? So we found it actually. We found this is x minus 1. So we know square root, that means x minus 1 must be greater or equal than 0. Alright guys, I just realized that I made a mistake. Okay, so I gotta go back to check this. It's not x minus 1, it's actually x plus 1. Okay, because when we add 1 both sides, so I made a mistake there. I apologize for that. So let's just go back. Let's just go back here. So I fixed this part, so that makes sense. Okay, we're gonna have x plus 1, and then in this case that will be x greater or equal than -1. So on the number line, you're gonna have something like this. We're gonna have greater or equal than -1. So that's why you're gonna have -1 and then to the positive infinity. Okay, guys. So that is your 2.7 lesson. Okay, I really appreciate your hard work. Thank you so much for watching the video. See you guys next time.